This is the second part of the review video. Let me review for number 19 and 20. Both of these have exponents. So the 2 will travel to the front of the ln and the x stays behind. Then y to the second, the 2 travels to the front with the ln of y, and then the ln of z. On number 20, we have ln in all of our terms. Notice that I have x plus 3. X plus 3 cannot be split up because of the plus symbol. So he stays as his own term, x plus 3. The minus comes from the division here. That makes the minus here. And then I have 2 terms underneath because I can rewrite this as x times y. So I have the ln of x plus the ln of y. Now to make sure that I keep both of those things in the denominator, I have put them in parentheses. For the next set of problems, you're simply doing the opposite of what you just did in expansion. So what I have in both of my terms is the log of base 2, and I know that this is 5. I have multiply because I have add, and I'm going to multiply that by x. For the next one, I have ln in both terms. I have x on the top, and I have a division because of this minus sign. Then this 1/4 out front tells me that that's an exponent. So this is y to the 1/4 power. Because in the directions you have no restrictions of how you're to give the answer, this is also correct by using the radical sign. Either answer is correct, and how you write it is up to you. For the next one, I have the natural log for the beginning. This is x to the 3rd for my first term. Remember, this is my exponent. And then for my second term, I have x plus 1. And in front of that term, it is a 2, so it's raised to the second power. And those 2 are multiplied because of that plus. For my last one, I have 2x minus 1 as my first term. ln is in front of everything. It is raised to the 1/2 power. And then it's divided because of the minus. And then my second term is x plus 1. And because of this 2, it is raised to the second power. Now, again, because there are no restrictions on how you write your answers, you could have also written the top underneath the radical sign. Either one of these is correct. Moving on to solving the equations, each of these, remember that your logs must be on the side by themselves. So I have an exponent of base 8, and the way I get rid of that is to raise it to the log of the same base. So I'm going to do log base 8 on both sides. What you do to one side, you must do to the other, right? All right, so the log of base 8 and then the base of my exponent cancel each other out, and I get x is equal to the log base 8 of 512. Well, you can't put that in the calculator, so you're going to have to put into the calculator the natural log of 512 or the log of 512 over the log of 8. And from the calculator, you will get 3. For the next one, the opposite of e is ln, the natural log. So we're going to do that on both sides. So ln and e are going to cancel each other out. So I have x is equal to 2.485, which is the natural log of 12. For the next one, I have a log, so that means I have to create an exponent with the correct base. And my base in this case is 4. So I create an exponent at base 4, and everything goes to the exponent. what I do to one side, I must also do to the other. So the log of base 4 and the exponent of base 4 cancel each other out, and x is equal to 4 squared or 16. Now, some people ask me, can I rewrite this equation as an exponent? Because if I do, I can use the base of 4, raise it to the exponent of 2, and that is equal to x. It does not matter how you solve these as long as you solve. So if I have the ln of x, the opposite of ln is e. So I'm going to create my e on both sides, and everything goes to the exponent. It doesn't look like it's raised to a power. That. Okay, so the ln of x. So e and ln cancel each other out, so x is equal to 54.598. And you're simply putting this in the calculator using your e button. On the last couple, then your number 28 is left off my page. E to the 2x is equal to 12. Okay, the opposite of e is ln, so we'll do ln to both sides. Remember, you have to make sure that this is isolated before you ever start. So ln and e cancel each other out, so 2x is equal to the ln of 12, which is 2.485. And then we're going to divide that by 2 to solve for x. So x is 1.243. In number 29, you have a 3 out in front of your e. So that is the first chore, is to get that e by itself. So I have to divide by 3. It's multiplied right now, so the opposite is going to be to divide. And that's going to give me 44. To get rid of e, I need to do the natural log, or ln e, and natural log of 44. These two cancel each other out, so I have negative 5x is equal to the ln of 44. And you can put that in the calculator and get your number if you want to go ahead and do that. But I put it in as ln of 44 divided by negative 5, and x is equal to negative 0.76. For number 30, the first thing I have to do is I have to isolate that 2 to the x. So I have to get rid of my 13. So once I do that, I get 2 raised to the x is 22. Then I have to get rid of the exponent with this base. So I need to do the log of that base. So these two cancel each other out, and I have x is equal to, and I'm going to have to put this in the calculator. So I'm going to have to do log of 22 over log of 2, or natural log of 22 over natural log of 2. And that's going to give me 4.46. Looking at the next couple of problems, as we go through to number 31, again, you have something that has to be moved. You have a negative 4 out front, so you're going to have to move that first. So you need to divide both sides by negative 4, and you get 5x, 5 raised to the x is equal to 17. Then you need to do the log of that base. So log base 5 of 17. Again, you're going to have to do a change of base. So that would be natural log of 17 over natural log of 5. And that's going to give you 1.760. I think there's 3 that follows that. On number 32, this is one of those problems where you work smart, not hard. This problem can take you a very long time to do, but if you start off looking at what you already know, then you don't spend a whole lot of time. I know the first thing I have to do is I have to isolate these, so I'm gonna have to subtract them. So the only way I can get rid of E is to do natural log. You know that if I do the natural log of a negative number, that is not possible. So this is actually no solution because if I take the next step, my calculator is going to give me an error. So for number 33, I have natural log of 3x is equal to 8.2. So the opposite of natural log is E. So E on both sides. And then E and ln cancel each other out, so that gives me 3x is equal to 3640.95, and divide it by 3. So x is going to be equal to 1213.65. All right, last two. 34 is 2 natural log of 4x is equal to 15. So we have to get rid of this 2, so divide everything by 2. So natural log of 4x is equal to 7.5. And to get rid of natural log, we have to do E on both sides again. And this is probably the hardest part because that looks weird. And I get it, it looks strange, so you're not sure if you're right. So this is 4x is equal to 1808.042, and you're going to divide that by 4. So x is 452.0. All right, on number 35, the thing you need to remember is when you have log all the way across, the log drops off. So I have x plus 2 minus x equals x plus 5. These two guys cancel each other out, so I have 2 is equal to x plus 5. Subtract 5, so x is equal to negative 3. That is the review. If you can accomplish what you have on the review, you should be able to do well on the test tomorrow. Can't wait to see you then.